Section 8.2 is our next one. Confidence interval for one population mean when the standard deviation is known. When the standard deviation is known. I think I got that backwards. Okay, so forgive me for that. All right, so here is our procedure. The one mean z-interval procedure. And so you're going to be given a confidence level. We use that confidence level to find our z-score. We use our z-score to help us find the confidence, and our sample mean to help us find the confidence interval, and then we can interpret the confidence interval. So, for instance, all right, well, first of all, let me not get ahead of myself. Need to know facts about one mean z-interval procedures. Normal population is an abbreviation for the variable under consideration is normally distributed. So keep that in mind. Works well even if the variable is not normally distributed and samples are small. Watch for outliers because they call into question the assumption of normality. So when do I need to use this? Well, for small samples, the z-interval should be used only when the variable under consideration is normally distributed or very close to being normally distributed. For moderately sized samples, the z-interval can be used unless the data contains outliers. Or the variable is far from being normally distributed. For sample sizes of 30 or more, the z-interval procedure is going to be able to be used without restriction. However, if outliers are present and their removal is not justified, you should compare the confidence intervals obtained without the outliers to the confidence intervals obtained with the outliers so that you can see if there's any real difference, okay? If outliers are present, but the removal is justified and results in the data set for which the z-interval procedure is appropriate, the procedure can be used. Okay, so these are when it can be used. You need to kind of commit this stuff. And I don't like to use the word commit to memory because you'll commit it to memory if you go back and look at this over and over as you're studying through and working these problems. Okay. With anytime you're doing data analysis, make sure you look at the data as a whole. Apply any things like normality plots, histograms, box plots, so that you can determine if this procedure can even be used. I mean, because outliers has a lot to do with that. So make sure that you can determine if it can be used. All right, so for example, the Bureau of Labor and Statistics collects information on the ages of people in the civilian labor force and publishes the results, in employment and earnings. 50 people in the civilian labor force are randomly selected. 50. So what does that automatically tell us? Well, based on our last slide, we can use the z-interval without restriction unless there is a major outlier, okay? So outliers is what we'll have to be looking for. Find a 95% confidence interval for the mean of all people in the civilian labor force. Assume that the population standard deviation is 12.1. All right, so first and foremost, what we want to do, step one. Step one is going to be, before you even start this, you need to do a normality plot, see if it's normally distributed. You can do box and whiskers. They will show outliers, but I like normality plots to show outliers as well. Okay, so I think they're more consistent. So if you look at for instance, if you look at the next slide, here's the histogram and the normality plot. As you can see by the normal scores and things, one, it's normally distributed generally, and two, there aren't really any outliers. If you do the box and whisker plot, which is actually given to you on page 314 in your book, if you go look at that, by the Bots and Whisker plot, you're going to think there are two outliers, two major outliers. But when you look at the normal plot, probability plot, you can see that they're not, the outliers aren't really life changing. So with this one and this one, okay, they're not really life changing. So we could live with those, and we could go about doing our procedure. So you need to do that first and make sure it's viable. Okay, that's step one. All right, so let's go back. Now that we know it's viable and we can use the one mean z-interval procedure, now we can go about using it. So, so for instance, step one, or step two now, your book would call this step one, but I call it step two because looking at those graphs are step one to me. Step two, sorry about that. Computer is going haywire. Excuse me, folks. Alright, so step two, what we're going to do is there's a 95% confidence interval. So what we need to do is, with step two here, subtract 1 minus 0.95, and that gives you 0.05. This gives you our alpha for z sub alpha divided by 2. Now, we're going to have to use z sub alpha divided by 2 based on our procedure to help us get the our confidence interval. So go ahead, substitute in 0.05 divided by 2. And so that gives us z sub 0.025. Now, it's been a while since we've done these, so how many of you really realize what we're doing here with this? Well, remember what this right here stands for. This is the area of the normal curve to the right of the z-score. So what z-score has an area to its right of 0.025? 0.025. All right, well, if you go back and look at Table 2, if you remember, Table 2 represents area from the left. So if you remember how to do these from our previous videos, we say 1 minus 0.025. And that gives us 0.9. That gives us 0.975. Okay, this is the area under the standard normal curve to the left of our z-score. So you need to go to Table 2 in the index, in the appendix, like we did earlier on in Chapter 6. You may want to review Chapter 6 for this. Go back to that Table 2. Look for the area of 0.975 in the Table 2 and tell me what the z-score is. What z-score goes with the area 0.975? And you should get 1.96. So remember, you have to subtract this right here from 1 to get the area to the left, because that's how it's read in the tables. This circled part here means area to the right. So 1.96 is the z-score with 0.025 area to the right under the normal curve, okay? So use that to get your 1.96, just like we did in Chapter 6, okay? Now, here's why we get this z-score. Step 3. Step 3 allows us to calculate the confidence interval. And here's what our confidence interval equals. X bar, we should know that from our last section. Z sub alpha divided by 2 times the standard deviation over the square root of n to x bar plus z sub alpha divided by 2 times the standard deviation over the square root of n. So we just found z sub alpha divided by 2. That's 1.96. So we can plug 1.96 in here. 1.96. We solved that. Now they told us in the problem that the standard deviation was 12.1 and that there are 50 people. So we can actually find this other part here. This is going to be 12.1 divided by the square root of 50. And this is going to be 12.1 divided by the square root of 50. Okay, now the only thing we're lacking to be able to compute this, and if you want to put a parenthesis around that, that's fine. The only thing we're lacking is x bar. So take all of this data and find the mean. So add it all up, divide by 50, and you'll get 36.4 is what you should get if you do that for the mean. So we can actually take 36.4 and plug it in right here. Now go ahead and do your math. Punch all this out. And what you're going to get for this left part of the interval here, from the left part here, and then from the right part, which starts right here, you'll get a different thing. So from here to here, okay, you should get 33.0, if we round to a tenth, to 39.8. Now this is your CI. This is your confidence interval. Okay, this is your confidence interval. All right, now just do the math. You should get 33.0 to 39.8 there. Now, what does this mean? Well, what this says is that we can be 95% confident that the mean lies in this interval. We're 95% confident that the mean lies in this interval. Okay, 95% confident that the mean lies in the interval from 33.0 to 39.8. Now that's the your book's going to call it a 3-step process. I call it a 4-step process for getting your confidence interval. Okay, so keep that in mind. Make sure that you are, if you have any questions, make sure you ask your instructor so that you can understand it. Typically, I find that students want to watch this video more than once to see how to do this. And I also find that students want to go back and review Chapter 6 for the z-scores and things. So make sure you go back, watch those videos again, and I think they'll help you understand a lot of this. All right, so 95% confident that our mean lies in that interval. All right, so confidence and precision. Okay, for a fixed sample size, decreasing the confidence level improves the precision, and vice versa. Decreasing the confidence level increases the precision. So if we settle for a less confidence that U lies in our confidence interval, we get a shorter interval, essentially. However, if we want more confidence that U lies in our interval, we settle for a larger interval. So decreasing the confidence level improves your precision. Okay? Let me say that one more time. Decreasing the confidence level improves your precision. Basically, it's this. The confidence level of a confidence interval signifies the confidence that we have that it's actually in that interval, that the mean is actually in that interval. So the length of the interval indicates the precision of the estimate. So long confidence intervals indicate poor precision because you're having to give yourself a lot of room for error. Smaller, shorter confidence intervals indicate very good precision because you're kind of pinpointing it in You're kind of zeroing in on it. Okay, hope that makes sense. The difference in confidence and precision there. All right, that's been section 8.2. Please ask your instructors if you have any questions at all.